Welcome to Homework Lib.
Hi, so over here we're going to use the component method of vector addition to find the resultant of the four displacement labeled here on this picture. Unfortunately for us, the information for the displacement on C is missing on the image, so we're going to just follow the procedure in order to get our result. Okay, so first thing that we need to notice are going to be we are going to be able to find the x component of A. This is going to be AX. The x component of B, that would be somewhere around here. I'm going to put it on this same plane. This would be bx. And finally, the x component for C on this direction, cx. Additionally to that, you're going to notice that the only negative value is going to be the component for D on the x direction. So, in order to find the correct projection, what we need to do is employ the angles and trigonometry in order to find our result. So, in this case, the sum on the x component would correspond to adding up the x component of A plus the x component of B plus the x component of C plus the x component of vector D. For the case of A, the angle that is employed is the one over here. Thus, the function that we need to apply is going to be the sine function. This is going to be the opposite cadet of the right triangle generated by this vector over here. So, in the case of A, we're going to get magnitude of A times the sine of 60 degrees. Plus, now let's do the same thing for B. The component is also going to be employing the sine function, since the angle over here generates the following right triangle with 20 degrees as the angle. So this becomes plus B times sine of 20 degrees. Next up, for the C component, what we're going to find is going to be, now we need to focus on this right triangle. And as you can see, the angle that the x component is going to reside as the opposite cadet instead of the adjacent cadet. That means that we need to employ the cosine function. Thus, now, let me erase this part over here to have more space for later. Now this would become plus magnitude of C times the cosine of 36 degrees. And to this quantity, we now need to subtract minus the magnitude of D times the sine of 36 degrees that we have over here. So all of this is going to give us the x component of our vector. In this case, we're not going to proceed with the result since we are missing the value for the magnitude of C, but this is going to be the method to get the x component for the vector. And the resulting number is going to be, let's call it resulting x. Okay? Now, for the y component, the quantities that we need to add up are going to be the y components for each of the vectors. So now, this is going to become magnitude of A times the cosine of 60 degrees plus the magnitude of D. D is the only other vector that will be pointing up on our diagram. As you can see over here, this is dy. Here we have ay. And for B and for C, we're going to have B on the y direction and C on the y direction, both being negative values. So let's write them in order. Now we're going to have minus the magnitude of B times the cosine of 20 degrees. For C, it is also going to be negative, but now we need to consider the adjacent cadet, so this is going to be the sine of 36 degrees minus magnitude of C times the sine of 36 degrees. And finally, for D, the result is going to be positive, so plus magnitude of D times the cosine of 36 degrees. Let me make some space over here. So actually I had to put it down just to have enough space for the picture, and the sum of all of these numbers is going to be the resulting vector on the y direction. Thus, the resulting result can be written as resultant on x on the unit vector I direction plus resulting on y times the unit vector on the y direction. And with that, it would be all. Thank you very much and have a good one.